Dear ladies and gentlemen, it's a pleasure for me to stand here. Thank you very much for the invitation to all the colleagues from Serbia. It's really an important day as well for me to be here the first time in Belgrade, which is a pity not to have been before here, but tonight and tomorrow hopefully we will see some of the things. Well, it's my task today to talk about more an engineering perspective maybe, since I'm a river engineer, and to try to combine research and management a bit with a focus on the whole Danube. And you see in the background of the first picture also the view onto the Danube from the delta actually. So what I'm going to talk about is to introduce very shortly, not to overstress the time, and then to give you some indication of the problems and objectives I want to discuss with you. Then more focus I want to put on the current status and the prospects on the Danube River as a whole, and then to try to bridge the gap between research and management. Being an engineer, it's always a task also to try to find solutions for the practical implications, but at the same time we know that fundamental research is also needed and necessary, as it was already presented today several times. Then I would like to give some outlook from my perspective, conclusions, and eventually also some recommendations, what can we do from my point of view in the future there. So to introduce the problems and objectives, actually, as we all know, on the one side, we have a change of the mode, of the attitude towards rivers over time. I mean, after the Second World War, for example, in Austria, where I come from, there was the saying of the 10th county, of the 10th state, by getting land from the river, by reducing the width of all the rivers, regulate them to get more land for agricultural production. That was very clear. And later on, it turned out that there were some ecological problems, and so the biologists came on the scenery and said we have to restore the rivers, but there was no idea how to do it. So at the end, people thought maybe it's only then the biologists or ecologists that should find out how to do it, but it turned out that without any engineering approaches, it's also not possible. So what is the third phase, to my opinion, and this is the backbone of this talk, is how can we combine those two parts, the ecology and the economy, if you also wish, in that context. So the objective then is to discuss this on the basis of the hydromorphology. Hydromorphology is a new term created by the Water Framework Directive. It's an artificial term combining hydrology, hydraulics, I would say, with the morphology, with sediment transport. And so we have to look first, what is the situation now? This is the major part of my talk, in order to come up with some future discussion points and ideas what we should do. And I think Serbia plays an important role here in the whole context, as you will see. So what I try to go through is I divided then the Danube into 4 sub-regions for some reason. The first reason is, of course, we can say the upper Danube, which is more or less going a little bit downstream of Vienna, is the steep Danube. It's also named the gravel bed ridge. So we have grain sizes of gravel size. Downstream in Hungary and further downstream we switch partially to sand bed, and then we have the Iron Gate, which was originally the steeper part, of course. Then we have the flat part in the lower Danube again, in the border between Romania and Bulgaria. And then we have also the delta as a separate unit, and I will try to talk about these different problems or different situations, find also out similarities along these 4 categories. What you also can see in the background are these yellow-orange dots there, and they are hydropower plants. So the whole Danube basin is, of course, a basin, and there are many rivers, not only the Danube main stem, but also Sava River and other ones, which are used for hydropower, and this has, of course, some implications. And you see more dots in the upper parts. Austria, for example, is a small country with about 8 million inhabitants, but we have about 5,200 hydropower plants in this relatively small country with about 72,000 square kilometers. So there's also a wave of small hydropower plants coming down to the Balkan areas, and also maybe big discussions. What we think is we are not in the situation to talk we should have hydropower plants, yes or no, but it's a question which type of hydropower plants, and can we not learn from the past, which is, I think, important. We should have also some innovation in this concept. So I want to concentrate, having said this, only on 3 parts, because otherwise it's too long, my talk. These are more or less driving forces and impacts from the perspective of biologists. On the other side, economists would say they are also causes of some income. So we have hydropower, flood protection and navigation on the Danube. We could also add climate change, land use change, and point of view source pollution. This was also mentioned by several speakers before. And I think that climate change, of course, is an overarching topic which has to be regarded in all those respects. Now, if we start now with the hydropower, this is just a longitudinal section, and it clearly shows also in the upper part, the steep part, when it goes down to Hungarian plain, when it goes down to Romania, Bulgarian plate, it's a lower slope with sandbed rivers, and we have here the iron grade 1 and 2. All the previous people were already clever enough to find out where is the best position for large hydropower. And also we have some free-flowing sections in between the hydropower plants, which is one here, a very long one, over 1,000 kilometers, a second very large one upstream of the iron gate 1 and 2. Then we have here a smaller one, which is upstream of Kapčíkovo, which is between Austria and Slovakia, which is about 48 kilometers. Then we have another one, which is only about 30 kilometers, which is Wachau, which is a very nice area to go there. And it was still kept out because it's a UNESCO Natural Heritage. By the way, this one should have been completed in about 25 years ago, and there was a big movement against it, and the Green Party in Austria was founded because of the opposition of this Heimburg hydropower plant in the Austrian territory. And then we have one more left, a lot of political discussions in Germany, Straubing, Frieshofen, all the CSU, CDU, and there's always not the same opinion between Berlin and Bavaria sometimes on this. There's still a lot of discussions, should they build another hydropower plant or is it a free-flowing section? Now, why I'm talking about this? So far, we isolate the two things. We have hydropower, reservoir schemes on the one side, and we have free-flowing things on the other side. But we cannot isolate them, and I will show you later on this issue. Why not? One example is the sediment transport, which I am doing research a lot in this area. We have, let's say, an increasing difference between having too much sediments in the reservoir and having not enough sediment in the free-flowing section. And this gives now headaches, especially in the Austrian and German part, but also in other ones. Because in Austria, when you would take sediment out from the reservoir, you would have to dump it on a waste disposal site. And the cost to dump 1 cubic meter in Austria is about 20 euros. Now, if I tell you that the Danube transports through Austria, cross-section, about 6 million tons per year, this will be, of course, a big amount of money if you want to do that. But I will come back to this later on. Second part of usage is navigation. It's the environmentally friendliest transport mode. If you compare with the railway and trucks, one ship can transport about 90 wagons of a train or about 150 trucks. If you would transport the raw iron or if you would transport the coal, for example, to a factory in Austria by road or railroad, it would be much more expensive and environmentally costly. So that's one reason why they want to increase the transport rate. This is an Austrian number. I think in Serbia maybe it's larger. From 10 million tons to 30 million tons, 3 times from now. To give you a comparison, in Germany the Rhine is a very important life vein, and the Rhine transport about 100 million tons per year. Now you might ask, the Danube is larger than the Rhine. That's right, but the distance is longer, and the Danube is much more varying in the discharge, so the predictability is quite more difficult. And we have the free-flowing sections with a lot of bottlenecks. And then it turns out the question, do we have to regulate more the Danube versus restoration? Do we get more problems with that? And how can we do that? Which measures should we use? It's another area of conflict in this domain. When it comes to the flood risk, whatever you take, there's also some numbers of 80% loss of original floodplain area, especially in the downstream part. And there's a lot of ICPDR thoughts to improve the situation, to restore floodplains, to reconnect them, to shift dikes, whatever. It's a lot of costs, and we have to clarify if this is really meaningful. But maybe there's a way to combine also the ecological functionality of floodplains with what we need for flood protection. And there's a paradigm change. Like Austria had the idea to get rid of the water as fast as possible, as soon as possible. So we narrowed the river, we increased the flood wave, and this is of course for downstream countries, or could have an impact. So we have to think about this as well. Then we have the ecology, one example here. This is what you know, the husa, this sturgeon fish, larger one. And this was migrating, and I couldn't believe it because I'm not a biologist. It was moving to Ulm. Where is now Peter? Somewhere in the auditorium. So this is a very big fish. It came up, the Sava or even the Traver here, whatever. So then, of course, we have the interruption of the continuity with the hydropower plants, not only Iron Gate 1 and 2, but also Gabčíkovo, so it cannot swim to Vienna anymore, about 2,000 kilometers. It's close to extinction, I learned, and when you look into this fish, it becomes quite obvious. This is a fish that can be maximum 4 meters long at a weight of about 1 ton. And the history books showed us that in the city of Vienna, you could buy this fish. There are pictures, drawings basically, they carry this fish into the center of Vienna to eat it. And now the European Union wants then now to restore the migration route, which would mean a fish ladder at the Iron Gate 1 and 2. There's a big debate. Is it meaningful? Is it not meaningful? But as an NGO, on the other side, we are asked then to provide information how to improve the situation with the fish ladder there. I'm not saying if this is good or not, but it is another domain, the continuity question, and it's not only the sturgeon, it's also other fish we have to look at. So if I combine this, and maybe first before I come back to this, I have to also say that all those different usages, they have a backbone, let's say European legislation. We have for Ecology Water Framework Directive, the Floods Directive, we have the Renewable Energy Directive, and they have also the NAIADES program for navigation. So all those want something from the same river. And this is a big issue for the engineering side as well. How can we fulfill this? Now you cannot do everything at one stage, so maybe we start with the sediment transport now. What I have here is a figure showing the situation before and after, let's say, the main wave of hydropower plants that were developed in terms of suspended sediment transport, which is maybe grain sizes smaller than 1 millimeter. I know there is a variable grain size of the critical grain size, but at the end, if you look at the Black Sea, originally, if the data are correct, and we have to verify them, of course, we had about 50 million tons of input into the Black Sea. What we have nowadays is about 19, 20, 21 million. It's less than half. Now you will see in some tables later on that this has a consequence. Less than half of what was originally there means less sediment. What is the consequence? We have erosion there. In the Black Sea, the Romanian colleagues, they give me data indicating that the coastline is eroded. The sand beaches get lost at a rate of about up to 25 meters per year. 25 meters going back of the coastline. Now maybe you could say in the Black Sea it's not so dramatic like in Japan, but the Japanese colleagues, they try on the engineering point of view, and I saw it last year, solutions of bypass systems, for example, with hydropower plants, in order to restore the coastline, because they are very sensitive for tsunamis and so on. When the coast is eroding, Tokyo and all the big cities along the coast are endangered in a way. But it's also economics, because sand beaches we all like in the summertime, like it was now, or it is now. So when they are eroded, like in the Adria, the Po doesn't bring any sediments anymore. Or if you look to Nice or other places, they have to artificially dump sediments in the coastline. So this is a question, and we would have to take it out somewhere, maybe to dump it with a lot of costs as well. So there's a too much and not enough question. For the bed load, it's also more in the upper part an issue. So we have also almost reduced the bed load transport. So we get bed erosion. And I can show you some of the pictures of this erosion later on. But also, if you would consider sand as a bed load, and there is some debates, where is the boundary, and is our measurements able to capture the sand transport? And we doubt about it. We lose the sand in the measurements because for the suspended sediment it's too large, and for the bed load it's too small, because our samplers normally have a mesh size which excludes this part. So we cannot really say in the downstream part much, but in the upstream part we have a big reduction with also erosion of the riverbed. Now this leads to something. I don't know if you can see it. You have a surplus, reaches with too much, and reaches with not enough sediment. You can do a simple balance with the data I have available, but it's not enough for the future to build something out of it. But if you take these simple data and compile them and put them again in the upper, middle, and lower Danube, what you can see is that in the upper Danube, we have a situation that we have surplus dominated areas, so we have more reservoirs where the sediment is kept back, so to say. In the middle part, it's not equal, but it's more equal than in the upper part. But if you look in the lower part, downstream of Iron Gate, we have only a deficit area. And I was not aware of the consequences until 2 years ago when we did a project also in Romanian-Bulgarian project together with some friends there, what is going on in this area. And this, of course, as a next step, has here a consequence of the alteration of the morphology, which is quite clear. Not only the erosion and the deposition, but also the narrowing of the river, the riprap, what we need, of course, for flood protection, but the question is how can we modify and optimize this, leads then to a situation that on the average we have here in the upper part more red zones, that means hardly and strongly regulated, and it's more green maybe in the downstream part, although I know that it's a heavily modified water body in Romania, Bulgarian region, but there's a lot of debate if this is really the case from the morphology or not. Now let's look do a close-up into some of the processes on a sectional scale, look into some of the ridges. Now this is how the Danube looks like east of Vienna, downstream of Vienna, free-flowing section, no impoundment, but old regulations, old low-water regulations, groin structures, orthogonal groin structures, longitudinal draining walls, narrowing of the river by about from 3 kilometers to about 300 meters, so 1/10 of the width than before. No side erosion possible, of course. And at the same time, this is a national park. So this is a contradiction in itself, and I worked since 10 or more years in this region as well to discuss that navigation says we want 2.5 meters water depth for low water conditions. And ecology says you don't get that. Or navigation would say 2.7 meters. So at the end of the day, this is another, not only the sediment budget, but also this regulation gives some discussion. Now, if you look at some of the outcomes of all that, then you can say we have a trapping efficiency, we trap sediments with reduction of the bed load input, for example, 95% or 90-95%. We have a sediment deficit in free-flowing sections, we have a reduction of the river length, maybe 15% in Bavaria and Austria, down to 10% of the riverbed width before, riverbed erosion downstream, disconnection of floodplains, prevention of bank erosion, and so on and so forth. If you look at our region now here in the upper part, you see this is over time the bed level change. And you can see it's about 1 meter lower, the level of the Danube River. And I have not time to go too much into that area. But people would say in Austria, okay, what is the rate of erosion per year? And you would come up with a rate of 2 centimeters per year. Now people would say that's not much. And in some places we have maybe 5 meters of gravel left. You know, the gravel, the stones, they came from the Ice Age, which finished about 10,000 years ago. But now if you have only 1 meter of gravel left, and it's 2 centimeters per year, you don't need to be a scientist to calculate how long it takes until all this is gone. And then the question comes to us, what is then? What is then? Well, the easy thing is, not easy, but you could drill a hole there and could see what is the subsurface material, what do we find there? We find marine deposits, because in ancient times, in Pangea times and afterwards, we had a marine environment here. It was a sea. So fine sediments are there. Now, if you know, the river might be, that comes into this, in the steep area like in Austria, and it goes into fine material that can be a canyon type of erosion, which we call riverbed breakthrough. And I have no time to show you some pictures, but we have observations from the Salzach River that can be in 4 hours, 5 hours in 2002 flood, for example, that the whole river cuts down about 4 or 5 meters, the water disappears in this canyon, and on the gravel bars which are dry, there's no water anymore. Now we don't think that the Danube will disappear, but it can be a canyon type erosion, what we think, about 80 meters wide, about 10 meters deep, and then you have cataract areas with 4 meters per second flow velocity, so the shipping will not be possible at that stage. So we cannot go endless in this direction, we have to do some countermeasures. But what is the countermeasure? One idea is to put more gravel in. Austria dumps about 200,000 cubic meters of gravel into the Danube, but after 48 kilometers it ends up in Gabčíkova, and Slovakia takes it out for free for road construction. And the question is, where do we get this material from? And it's millions of euros per year put into the Danube River. So we have to have more intelligent additional measures to go for. Second part from the upstream side, we all know the flood of 2013, which was a major flood, a 200 years flood in Austria, and we had been asked to measure the sediment transport at 2 sections. How much comes from Germany and how much leaves Austria? So what we had the idea is we drive with the cars along with the flood wave. And I told my people they should measure exactly on the peak of the discharge. So this is the blue line here. This is the discharge, And you see they made it. They were there at this section to measure suspended sediment transport. But we had also a turbidity meter on the riverbank, and only afterwards we could see that we missed the peak of the sediment transport. We missed the peak here, The sediment was 1 day earlier, or even more than 1 day earlier, at this cross section compared to the water. Now, how can be the sediment faster than the water? So we got a headache, and we call it hysteresis effect. So the question, and we couldn't find out an answer first. We thought there's something wrong, but definitely the sediment was faster there than the water. The only explanation we find is it can be only theoretically when the source of the sediment is closer to the measurement point than the source of the water. In other words, it must rain somewhere in Germany or at the Inn River, and somewhere the sediment has a source which is more close to Vienna than the water source. And we found the solution afterwards, and I show you here. There's one reservoir, Aschach, at the Danube, and what you see here is time, it's a little bit small. You see the sedimentation rate here, it's about 20 million tons, it's about, cubic meters. So the sedimentation goes on and goes on. That means when you look here, this is in the 60s and so on. So the sediment goes on, no big flood, You get more and more sediments, it fills up, and you see an asymptotic approach. You could say, okay, it goes to equilibrium at one stage. People would say, it's fine, huh? Like for the iron gate, it would fill up. And when it's filled up, it's perfect, it's good. But then there comes a big flood, and we have to open all the sectional gates then, like in 2002. And what you see here is a remobilization of sediments in the order of 5 million tons within 2 days. And then again, the same process, it fills up. That's no model, physical model, that's real data. And then 2013 occurs, and the same story again, you see. Now we have 5.5 million tons, cubic meters of remobilization. This is half of the amount of the whole flood. Now people go to court in Austria in order to blame maybe the hydropower plant that they may be responsible for the higher damages, because when you look at this as a consequence, sedimentation of meters in the floodplain, because it's also maybe a flushing. Now, then the consequence might be don't flush, but we have to open the gates, otherwise you get a catastrophic flood in that area or even a damage on the structure. So the question is, can we not optimize flushing? Can we not have bypass systems or new innovative solutions in terms of hydropower plants, especially for new constructions? And that's what I think is important for new hydropower developments on the Balkan area as well, to learn from these problems that were already demonstrated, and for existing hydropower plants to find some solutions that would be implemented. We have to get rid of this sediment not once in many years, with a kind of spilling effect, with a lot of court cases and damages. We have to find another way to get the sediment to the Black Sea. Now, if you look at the Middle Danube, you see here one cross section, that's the erosion from 1949 to 2003. You see, this is meters of erosion, 8.5 centimeters, 1 meter here, 70 centimeters, Nochmarosh, that was downstream of Gabčíkovo. So we see this erosion. Of course, one thing is the bed breakthrough. What we have is the gravel bed rivers. When you're in a sand bed river, you have, of course, also problems with the groundwater level that goes down. And many cities, I don't know how it is in Belgrade, but many cities depend on the river flow as well. But if you're in a reservoir, you don't have a problem at that stage. Lower Danube, lots of floodplains, but also the capacity is reduced. We have a lot of bank instabilities. I will show you a picture soon, and also suddenly erosion. People thought you shouldn't have theoretically erosion in the downstream part, because the slope is so flat, you would have a delta. Why would you have erosion? But data show here, unfortunately not many new data available, but it's the same story in the free-flowing section. Erosion here, in the cross section, erosion in the longitudinal section of 1 to 3.5 centimeters per year. So at the end, that is quite interesting. Suddenly we have erosion in the downstream part. Now what is the consequence? And you see no bank erosion in Romanian side and Bulgarian side, especially in Romania. So what is the consequence? If you go to the continuity equation of sediments, Exner equation, or whatever you take there, you can calculate easily. When the river goes down, erodes, the river gets wider. When the river gets wider, you get not erosion, but you get sedimentation in the first step. And we have suddenly more islands on the one side. We have more islands, so the islands increase from 93, it's only older data, but I don't have new ones, to 135 islands suddenly. Now the navigation comes and says, even each island is a bottleneck for us. We don't want the islands anymore, so we want to disconnect these side arms by structures. And Romania has, I think, 28 or almost 30 bottlenecks. But if we do this, of course we get more erosion on the other side. So the same story starts from the beginning. So it's not, without taking the sediment transport into consideration, this cut-off brings more erosion on the other side. And the classical example there would be the Kalarash-Prela bifurcation, some of you know that, where the Prela arm suddenly takes all the water. And now no water goes to Cherna water, to the nuclear power plant. On the right side, they have only 1 meter water depth now. So there's big discussion there, what should they do? Should they build a seal now? But they cannot build a seal as they want it, because the seal would prohibit sturgeons from migration. So there's no solution at the end, at the moment. So there is some thoughts what to do there as well. Now if you go to the delta, you see of course the transformation. Ceausescu did also some cutoffs of St. George Channel, and we have the Sulina arm and the northern arm, Kilia arm, and so on. If you put that together on a table, what I did here, just to try to give an overview, what can we see there? We have cut-offs, of course, 50 kilometers shortening is a lot in the delta. So we have coastal erosion up to 25 meters as a consequence of the whole budget deficit. And we have also here widening of the branches because of the erosion of 2 meters per year, widening. That gives shallower water depths for navigation on the one side. And we have also vertical erosion, which is here about 6 centimeters per year. Floodplain, and so all those things are interdependent. So the floodplain, the hydropower plants, the upstream sediment budget, and so on. Now the question is, with all that, it sounds a little bit negative, and maybe we have this development, but to bring it forward to some more proposals, what to do with this? I think the first thing is we have to think, and maybe you can't see it easily, but the idea would be not to work against each other, but somehow to get into a more interaction of hydropower, navigation, flood risk, and so on, to take on board knowledge transfer, management issues, scientific results. But the issue is, being a scientist, we are obliged to write SCI publications. But I'm not sure how many people of you saw any publication what I wrote, which is hard work. But also in Austria, maybe it's not realized because it's written in a special way. But the time lag from the publications on the science base to the management is very long. Maybe it's more than 10 years. So why can we not speed up this? And one idea was here suggested together with some people in a European project to do a data mining, or to try to get the knowledge that is there being available, to make it available to managing people. That means what we call a knowledge mining engine. It's not implemented yet, but it would be an automatic system taking out with keywords some of the publications, and then we also suggested that there would be a scientific committee, but also the administration in that, and we would have here a panel, so to say, to look into this automatically extracted material to find out, like diving for gold or something, is there something in the publications which we can use? That's one way to try to combine things. Otherwise, there's a big gap between the two parts. Another way is, the second way is, maybe you have heard of it. One idea was to go back to the Danube strategy, European Danube strategy. And so the idea was for the Danube River to have the Danube River Research and Management Project, it's called DREAM, with the idea as well to say we want to go from basic research to knowledge society, to go into that area. And we were very proud of that because we were the first scientific project to get the title flagship project. Now there are more, but at that stage we were the first ones. And Professor Veskovic, you know him very well from Novi Sad, the former rector now with the JRC, sorry. He was the one to sign that at that time. So he was very positive for the whole development. And we want on purpose to work also against the brain drain, which Peter before mentioned. Now what can we do there? What we found is that we have in some places very old hydraulic laboratories. People think or thought hydraulics is old stuff, we don't need it. But as I showed you hopefully before, we need to go more into this once more, together with biologists and so on. So we need those instrumentations and laboratories to get innovative solutions for that. So the idea would be to build 2 big labs, one in the delta, one in the upstream part, in order to have a big discharge, because what we found out also is when you go to a small discharge, you scale the sediment, you get into clay or silt material with cohesion, so the gravel transport is not really reflected. But we also want to go into the existing hydraulic engineering laboratories and try to get money from the European Union outside of the Danube strategy, because there's 3 no's. Yeah. So we have to go for bilateral projects, and I know from Serbia that there are a lot of attempts with neighboring countries to get some funding there. Third part is to use simulation tools. Like Jaroslav Czerny is very famous for having a very good instrumentation and development of tools here, and also other ones. So why not try to combine the efforts and see what is Jaroslav Czerny doing, or what is the university here in Belgrade doing, what are the people in Novi Sad doing, whereas what are people doing in Vienna, in Munich, in other places, in order to make some tools available. I'm not talking about the integrative model yet on the whole Danube, because the speaker after me will talk about some modeling of the JRC, for example, but I'm talking of hydraulics model in a way of combining the simulation tools what we have. Next point is field study sites. We really want to see, and I show you the map afterwards, to have a network of field study sites, to test the prototype measures in the nature, and then to find out if they work. If not, we have to go back to the lab. Next point, this is very important for me to mention. We have a research vessel in mind which should be positioned here in Serbia. And there was a discussion where to put it, and there was the idea to put it in Novi Sad at that time because they have a harbor to go. But I think it's very important that Jaroslav Czerny, the University of Novi Sad, together with the DREAM project, makes some next step, because I had a lot of discussions with Brussels. They are very in favor of the whole project, but I cannot write all the proposals myself, so we have to sort of, not only for the number 5 here, but in general terms, to make a roadmap to get some money, and it would be available for this. The research vessel, what is that? We would have a diving shaft, like in Germany they have it at the Rhine. You blow air into a tube, and so you can walk down a stair to the riverbed of the Danube. You could use it also at the Sava River, I think. And then we can take samples, but we can use the same instrumentation to look into bridge piers, into foundations of bank protection measures, and so on. And then we want, of course, to have a network of Danube River research institutions. And as I said, for Serbia, the University of Novi Sad and also Jaroslav Czerny is part of this endeavor. This is just a map to show you what I'm talking about. Here would be this research vessel, because we think that Serbia is in the middle, more or less, of the Danube and would be willing to host this. Of course, people that would take the research vessel would have to pay for using it. Maybe there are some people working on the vessel. But anyhow, the cost would be about 16 million euros, so maybe there's a chance to get some funding for this. Now, to come to some conclusions, of course the Danube is a totally disturbed system, and it's not a weighing what I say, it's a matter of fact that we have the influences, but it's not saying we can't do anything, it's the opposite. So we have to respect the hydromorphology in a way to find some improvement, but not only for the ecology, which is also important of course, but also for the essential part in itself of the hydropower navigation, flood protection. If we want to improve the situation, it's very much necessary to do that. I can just tell you that there's a big effort now from the ICPDR. Ivan is not here, I think now, to get a sediment transport project and also a floodplain project, which the Romanians want to do, to get into this area. And it's always not only from upstream to downstream the impact, but it can be also the other way around when we think of the impact of hydropower plants. On the other side, we cannot say what works in Austria works also in Serbia and vice versa, so we have to respect, of course, the conditions of those river sections. But at the end, we think that we can get into win-win solutions if we really want to go in this direction. So what would be the recommendations then from my side? I think in the upper part, river restoration, together with improvement for navigation, is needed. What we try to do in Austria is to develop new groin types. We have orthogonal groins. We want to make them declinant now. which can enhance river bank erosion. So the birds or whatever, the kingfisher has more habitat, but at the same time, those groins stop a little bit more the erosion because they are different working, and we have also maybe enough water depth for the navigation. I admit it's not easy, and we had first a half failure maybe, but now we modified them, and if anyone wants to see those groins, you are invited to come to look at. We have to work on the sediment continuity, new types, an innovation boost for hydropower plants. We should not use the old technology, which is fine in itself, but we have to use this and to further develop it. So it's really a must to go into new types of hydropower plants as well. And then, of course, I hope we can have new measures also for navigation and flood protection in order to get some win-win, let's say, proposals at the end. We have also the catchment sediment management concept as one idea, which could be an outcome, a guidance document, which could be an outcome of this sediment project. If it is funded, we don't know it yet, but in 2 weeks it should be known. Land use and also preservation, restoration. Whereas I forgot to mention that in the lower Danube, the preservation, but not only to keep it like it is, preservation means also to include the development. That means also get rid of the erosion in a certain way. So if I finish off really now, I think it's needed to define common goals between all those sectors. We need more interaction of research and management. The time gap between publications and implementation is too long from my point of view. We have to search for these outcomes. On the other side, we need integrated interdisciplinary steering and planning. That's missing in many projects from the beginning, to have interdisciplinary project teams. As far as I know, Yaros of Czerny is already in itself a little bit of interdisciplinary, has an interdisciplinary approach, but we have to, in general, in the whole Danube basin, to look at this. Then we have also to have a willingness to find a compromise. If everyone wants to get 100%, no one gets anything. And that's what I told the Romanians when we were in Brussels. You know, when they built this sill, the sturgeons cannot migrate upstream. Navigation people might say, I don't bother about the sturgeon. But we could prove that also the ships could not go over the sill, sometimes, some periods of the year. And the right arm has not enough water. So what is then the consequence? We have a lose-lose situation. A worsening of navigation and a worsening of fish. So the opposite is what we have to do. Another point is public participation. In Austria, last 10 years, I spent many hours and hours in such committees and meetings. It's really, as a scientist, sometimes really very demanding. But on the other side, you get a lot of things back in the discussion. And it's the only way now, the only way to do it. It's also by law necessary to include people. But how to do participation is not an easy task. But what I can say is, at the end of such a very long process, is that people learn to understand each other and see that maybe the engineers, what the problems they have, they learn to know why it is not working. People think the water must flow there. You show them a model, they even don't believe, but then when you see real measures, then maybe they come to the conclusion that it's right what was modeled. And finally, of course, we need the support from the politics, so it's a good sign. And congratulations that you could be able, that the president of Serbia could come today. I think it's a very good sign. Not in all countries the president would come to such an event, maybe. But it's also not only a one-day show or one-day meeting or one-day conference. It has to go on. And this is the most difficult part, at least in Austria, because the politicians, they change, different parties come there, and you start from the beginning. To discuss them. So a way to find a continuity also in the politics, apart from the voting processes, that's another issue, how we can go there. And we think we have to include more other scientists, from social science, as on the scientific part, to include them to show what we got. But finally, if we can do that, I'm really hopeful that for the whole Danube we can go into a win-win instead of a lose-lose situation. Thank you very much for the attention.